We'll start this one off by taking a look at this example. If you want to pause this and give this a shot on your own, I encourage that. I think that's a good strategy as we work through 4.2, graphing quadratic functions. So if you want to pause this one, graph it out, give it a shot, or at least try to make notes of every little detail that we have here, you can do that. But for this, I'll work it through kind of in a speed run mode. So we have our coefficients, -6, -4. Getting our axis of symmetry, -b over 2a. I know that I'm subtracting -4 up top, taking two versions of -6 in the denominator. Subtracting -4 gets us 4 here. 2 times -6 gets us -12, which we can then simplify to just -1/3. To plug this in is going to be a little bit of a headache, so I'm actually going to just plot this in with y equals, and I'm going to just go to town on really plotting this out as if I was going to graph this, but I'm not quite. This arithmetic's tricky, plugging in a fraction of -1/3 and trying to get an outcome in that equation, so I think this might be a good rule of thumb. So we have -6, we have x, we're squaring that. We have -4 times x. We also are deducting 5. So if we hit second and then trace, so I'm hitting second, trace, the value I'm looking for might be a little tricky to get. I know that it's graphed out, but I'm looking for where x is -1/3. And it's saying that this is approximately -4.333 repeating. So if you used arithmetic and you actually plugged in, you're most likely saying that the y coordinate is going to be -4 1/3. Writing this is totally fair game. As you can see from the calculator, I just hit second, trace, hit value, and then typed in -1 dividing by 3. So that's how I got that. I know my axis of symmetry just based off of the vertex, since this is -1/3, comma, -4 1/3. My axis of symmetry has to be when x is -1/3. I know that a is equal to -6, which is less than 0, which is implying that this opens down. So it makes sense that if it opens down like this, there's definitely a maximum highest point, a king of the hill, if you will. For y-intercept, the last number is -5. For this domain, all real. For the range, all the y values that are less than -4 1/3. So y values less than or equal to -4 1/3. If you're using bracket notation, you could say it's all the numbers from -infinity to -4 1/3. And as we see, when this is graphed out, this looks pretty atrocious, so we'll get a little bit more perspective on it by zooming out. We'll see if we can zoom in specifically on where we need to see most of the information. So we see that it's a ballpark for the y-intercept of -5. We can actually take a look at the table. We see that when x is 0, the outcome is -5. All the other numbers are pretty logistic, or they're pretty correct, or half decent to look at, even though our vertex is a little atrocious. Most likely won't have these types of vertexes on any quiz or test, but be open to them happening, just so that we have closure. This is a point, so you're -5 for the y-intercept. For example 3 and 4, that's all that we have for this section. So we're going from now vertex form to standard form. And so for this one, we utilize order of operations with PEMDAS. So if we look closely at this, is there anything that we need to simplify in parentheses? Should be saying no, x and -3 can deduct or be differences, that's fine. So parentheses, that's over. With exponents, we can definitely rewrite this x minus 3 being squared. So if you break this apart, if you want to actually write the binomials out like this, you can. I'm going to jump ahead real quick using either foiling or box method. X minus 3 multiplying with x minus 3 gets us x squared minus 6x plus 9, and then minus x. As mentioned previously, standard form is going to that original ax squared plus bx plus c form. So if I distribute -2, I have -2x squared plus 12x minus 18, also subtracting 6 here. What can we combine from here? You should be saying -2x squared can stay as is, keeping 12x as is, and then ending with -24. So that's considered the standard form. And it really came down to using box and FOIL method on the binomial being squared. We then distributed the -2 in with multiplying, and then we kind of added and subtracted the like terms at the end. Going to vertex form from standard form can be a little tricky. The main thing that's going to help us out here is that we know our vertex can be attained from this because we know that a is 2, b is 10, so we can get at least the x coordinate using -b over 2a, where b is 10, a is 2. So when we simplify this, -10 over 4, it's going to be equal to -5/2. And if you actually need a refresher on vertex form, so vertex form is using the a coefficient. We then have x subtracting the x coordinate for the vertex, and then also adding on k where the vertex is hk. They don't necessarily want to use h and y here because it could get a little messed up because we're already using x. And we always say that the equation is y equals all of that. So far we know that the x coordinate is -5/2. We know our a coefficient is 2, so we can start to piece this together with the standard equation, going to vertex form. So y equals 2 multiplying with parentheses x subtracting -5/2, where this is squared. If you want to rewrite this as x plus 5/2, parentheses being squared, that's a good look. But we still need to find our y coordinate for the vertex. So how could we do that? We know our x coordinate for the vertex. How can we get our y coordinate for the vertex? So if you plug in, that's an option. For this one, I'm actually going to start to plot this, and then I'm going to find what the outcome is if we have -5/2. So if we graph this as 2x squared plus 10x plus 7, if we then hit second and then trace for the value, we see this is graphed out, but the main value we're looking for is -5/2. So -5/2. It's totally fair game to use. It's saying that our outcome is -5.5. And we'll actually zoom in on this so we can see what it looks like. So as we see here, it's ballpark to be -5.5. So that means that for k, we still want to leave the rest as is, but now we want to subtract 5.5. Lots going on in this section, lots of steps, so please feel free to rewatch this if you need to. Reach out with questions if you're stuck.